Okay, this is lesson 76 for Algebra 2, for Honors Algebra 2. So lesson 76, notes on it. This is about finding, let me put my book in a better position. This is about finding polynomial roots. So some of it's gonna look familiar at first, and then we're gonna go into some new stuff. But for example, you've got 0 equals 2x times x minus 5 times 2x minus 3. So that's all factored for you. So you want to find the root, which again, y'all should be, this should look familiar. You should not think that that is something new. So one of your roots from the 2x is the 0, and then another root is 5, and another root is 3 over 2. Again, that's something you've done before, shouldn't seem new. Those are your roots. So then if we look at another one, say 0 equals negative x, and then x plus 4, and then x minus 1/2. So again, this x being outside that negative has nothing to do with it. This x being outside gives you the 0. That x plus 4 gives you the negative 4. And then that x minus 1/2, which, sorry, my skylight is making a real bad glare there, but it's positive 1/2. So that, again, that should seem familiar, shouldn't seem brand new to you at all. And I'm not requiring you to take notes, like I won't. You don't have to send a picture of them to me or anything like that. But, you know, taking notes is a nice deal, helping you learn. But that's up to you. But these are there to help you learn what's going on and remember what's going on. Okay, so let's see. So on this next one, it's not already factored. Those first two were factored, so we want to find the zeros. So we're going to factor it. So it looks like the first thing we can do is take out a 2x. That'll leave 3x squared plus 5x plus 2, if I haven't messed up anything. Then from there, you always want to try to factor. If it's an x squared, if it's a quadratic like x squared or whatever, you want to try to factor it. So that means I'm going to take the 3 times the 2 like we've done before, that's 6. And then I want the factors of 6 that give me 5, which would be 3 and 2. Because 3 plus 2 is 5. So then we rewrite. Again, this shouldn't seem new to you, although it probably has been more than 2 weeks since some of you have done any math. So anyway, but this should help you. And then you've got a 3x plus 2 and an x plus 1. Now I didn't say, you know, what are we taking out of the first two? It's 3x. That should be a review for you. And then I'm going to rewrite the 2x that I took out up here. Then I'm looking for the roots. I'm looking for the zeros. Remember, roots and zeros and x-intercepts are all the same thing. So this is 0 from the 2x. From the 3x plus 2, it's negative 2 over 3. Some of you get that confused and you put the 3 over the 2, but you shouldn't. You do the inverse operation. So if it's a plus 2, you're subtracting 2. If you're multiplying by 3, you divide by 3. And then since it's a plus 1, it's a minus 1. And those are your roots. Those are your roots, your zeros. So up here, when we say roots, it's zeros and also x-intercepts. You've got to keep that in mind when you're asked to find the roots, the zeros, the x-intercepts. It's all the same thing. Okay, so let's try another one like that where we have to factor and see what happens. So let's see, f of x is 6x squared plus 6x cubed plus 21x squared plus 18x. So here I'm going to take a 3x out. That'll leave 2x plus 7. That'll leave 2x squared, sorry, plus 7x plus 6. And then, so we have to do that advanced factoring thing again. So 2 times 6 is 12. And then I want the factors of 12 that give me 7, which would be 3 and 4, because 3 plus 4 is 7, and 3 times 4 is 12. So I'm going to do this strategically, 2x squared plus 4x plus 3x plus 6, because the 2x and the 4x have a better common factor, and 3x and 6 have a better common factor. So take the 2x out and you get x plus 2. Take the 3 out and you get x plus 2. Again, that shouldn't seem new to you. 2x plus 3, and x plus 2. And then I'm going to bring that 3x back down here just so I know what all my factors are. Then that's a 0, that's a negative 3 over 2, and that's a negative 2. Negative 3 over 2, negative 2. So those are your zeros, those are your x-intercepts, those are your roots. Lots of different names for them. Okay, then let's see some that have 4 terms. So f of x equals x to the 4th minus 3x cubed plus 2x squared minus 6x. So when they have 4 terms, you want to try to factor them, you know, like I just did this one here. When we have 4 terms, try to take out something out of the first 2 and something out of the second 2. So that's what I want to do here. I want to look and try to factor first before I do anything else. So take something out of the first 2, which looks like I can take x cubed. That'll leave x minus 3. And then take something out of the second 2, which it looks like I can take 2x out of the second 2. And that would leave an x minus 3, which is what I want. So then now we have x cubed, sorry, I went down a little too much, x cubed plus 2x as 1, and then x minus 3 is the other factor. Now this isn't done. This x cubed plus 2x, we need to do some more factoring on it. So I can take an x out and have x squared plus 2, and then x minus 3. Okay, and on this one, we're only going to want real zeros. We're not going to want anything but real zeros. And that's why we're looking for roots, zeros, and x-intercepts, because x-intercepts are real. That's where they cross the x-axis. So the reason I'm saying it here is because this is going to give us an imaginary root, and I'll show you why here in just a minute. So that x gives us the 0, the x minus 3 gives us a 3, and then this x squared plus 2, if we do inverse operations like I've talked about before, it's a plus 2, so we need a negative 2. If it's x squared, we need to take the square root. Well, if I take the square root of negative 2, that's I square roots of 2. That's an imaginary root. That's not a root. That's an imaginary solution. That's not an x-intercept like we want here. So just 0 and just 3. So we don't want any imaginary roots right now on this. We just want real roots. We just want the x-intercepts. So watch out for that. Let's see if I can find another one. Let's see if I can find another one like that. Hold on just a minute, because I want to show you another one. Well, phooey. Let's see. Maybe there'll be one in the lesson. I'll look here in just a second. Okay, so let's see. You're going to see something like this. This may bring up that again. X squared plus 4 minus x plus 3 and times 4x plus 1. So they've already, part of this, and this is equals 0. Part of this, they've already factored some of it. So if you notice this x plus 3 and this x plus 3, so we put that as x plus 3 right there, and then have x squared plus 4 minus, you have to be very careful right here. Very careful with that subtraction sign, because it's going to change all the signs after it. So what's going to happen here is it's going to have to be a minus 4x minus 1. Then when we combine here, I've got x squared minus 4x plus 3, because I combine the plus 4, that's a plus 4, and a minus 1. I know it looked like a 9, but it wasn't. It was a 4 from up there. So when I combine that plus 4 minus 1, I get a 3. So now I want to try to factor this one, which it's an easy factor, x minus 3, x minus 1. And then this x plus 3 is right here. So then I get a negative 3, positive 3, and positive 1. So that looked kind of nasty, but wound up being not very nasty. So let's do another one like that one. Let's see, 0 equals. Okay, so I've got x minus 2 times x squared plus 2 minus x minus 2 times 4x plus 7. So again, they've both got this x minus 2, so I'm going to take that x minus 2, and then what's left is x squared plus 2 minus, so watch that minus sign, 4x plus 7. So then minus 4x minus 7, because it changes those signs, that'd be x squared minus 4x minus 5. So that's what we have right now that we want to factor, which again, it's an easy factor, x minus 5x plus 1. Because negative 5 times positive 1 is negative 5, and negative 5 plus 1 is negative 4. And then this is x minus 2. So again, looked nasty, but not so bad on that one. Okay, let's even see one more. That one, let's see, 0, and I've got x plus 4 times 2x cubed minus 7 plus, is that what I want to do? X plus 4, that's 5 minus 3x. Okay, so let's see. Let's take that x plus 4, then 2x cubed minus 7 plus 5 minus 3x. So again, we take that, they both have this x plus 4 thing, x plus 4, x plus 4. And then I've got the 2x cubed minus 7 plus the 5 minus 3x. So that's going to give me 2x cubed minus 3x minus 2, and then x plus 4. So, a couple of different ways to approach this. We know one of the roots is negative 4. The other root comes from this thing, which we really don't have any way to factor it because of that 3. So what I want us to do is look on the graphing calculator, which I'm kind of going to have to zoom in for you so you can see. So go to your y equals, get everything off there, and then we're going to type in this 2x cubed, whoops, minus 3x minus 2. And all we're looking for is an x-intercept. So if this part doesn't have an x-intercept, then we're good. My calculator is probably still in trig mode from pre-cal, so let me fix my calculator right quick and have it graph. Okay, now see right there, it does have that x-intercept, so we're just going to eyeball it and say it's about 1.5. So we're going to put an estimation sign and say about 1.5. We know this exact one, and we get an approximation on that part. Okay, so that's what I'm wanting you to do when you see a problem like this, where you've got that x cubed that winds up here. Get your 0 from that for sure, and then put this in your graphing calculator and just eyeball it. Doesn't have to be exact, just eyeball that. It's about 1.5. So make sure you put an estimation sign on that one. This one's an equal to, because we got it from the factoring, and that one's just an estimation sign. Okay, let me see if there's another one where I want you to graph it like that. Yeah, here it is. Let's see. X minus 7 times 3x cubed plus 4 plus x minus 7 and then 5x squared minus 1. Yeah. Okay, so that whole problem takes me the whole board because I write huge. Oh well. Okay, so then going to take an x minus 7 and then 3x cubed plus 4 plus. Now, it's nice when that's a plus because we don't have to worry about these signs changing in that second set of parentheses right there. So again, what we're going to do is we're going to have x minus 7. We're going to have 3x cubed plus 5x squared plus 3. And then we're going to take that part to the graphing calculator and put it in. So clear off stuff, 3x cubed plus 5x squared. And y'all should know how to put this in your calculator. And then plus 3. And then we graph it. And we look for an x-intercept. If there's not one, if there's not any place where it goes across the x-axis, then we don't worry about it. Like we just take the one we can get from the factoring, and then there's not any from the other part. But here there is. It looks like it's about -2. So -2 approximately, but then this is exact because we get that from factoring. So the rest of that that's left over, use your graphing calculator on. Okay, let's see. And sometimes you'll be asked to solve. It's the same thing. That means you're finding the roots. 2x to the 4th equals 8x cubed minus x squared minus 13x. So 2x to the 4th equals 8x cubed minus x squared minus 13x. So now notice they put the equal sign here, so we're going to have to move. We're going to have some movement. You always want that lead that biggest exponent, the term that has the biggest exponent, that lead term, or what should be the lead term, to stay positive. It just makes things easier. So we're going to move everything to it. Minus 8 cubed plus x squared plus 13x equals 0. So we just moved everything over, changed all the signs. Now, if you notice, they all have an extra x. So take that out first. Rewrite. And then we're going to try to factor what's left, because it's 4 terms. So sometimes we could take something out of these two, which we can take something out of these two, 2x. Actually, 2x squared. And that would leave x minus 4. The problem is I can't take anything out of x and 13. So this doesn't factor. So you're going to grab your graphing calculator, and you're going to graph it on the graphing calculator again. So clear off what I had there. And put this one in, 2x cubed minus 8x squared plus x plus 13. So that's the way it should look. Graph it. And then again, we are just going to estimate. Now we have more than one. The other ones just had one. We're just going to estimate. Now that looks like it goes through -1 pretty well, and through 2, and then it's a little more than 3, so maybe 3.1, but we're going to count all of those as estimations. And see my estimation sign, the only exact one we've got for sure is 0, because we got that from factoring. These other ones are estimations. Again, estimations. So I estimated those to be -1, 2, and about 3.1. As long as I didn't mess up on my 1, 2, 3, yeah. So that right there, those estimations. And then that's 0. And notice it's x to the 4th. So how many zeros should we have? We should have 4 zeros. Some of them might not be real. For us, these are all real, but since it's to the 4th, we should have 4 of these like that. Okay, then one more thing I want you to look at, and you're going to need to make sure you've got your books open, and I'm going to just talk about example 5 that they give you. It says that the equation below, it finds the distance from the ground at time t for a ball thrown from a height h of 0 at initial speed of VO. Suppose the ball is thrown with an initial speed of VO5. So they identify everything. VO is 5, HO is 25. How long will it take the ball to hit the ground? And then they give you this formula. Okay, so they give you that formula right there, and then in the problem you're given that VO is 5. They give you that VO is 5, and they give you HO is 25. So we just plug in negative 4.9 t squared plus 5t plus 25. We want to know when it hits the ground. Suppose it's thrown with an initial speed, how long will it take to hit the ground? So that means that H, sorry, that H right there is 0. If we want it to hit the ground, that means hit ground, H equals 0. So that's why we put a 0 right there. And now we need to try to factor it, which it's not going to. So we could use quadratic formula. We did quadratic formula a little bit. Remember, quadratic formula is the negative b plus or minus square root of b squared minus 4ac all over 2a. So then I'd have negative 5 plus or minus square root of 5 squared minus 4 times a negative 4.9 times c, which is 25, over 2 times a, which is negative 4.9. So let me make sure I got everything plugged in. Negative b plus or minus b squared 5 squared minus 4 times negative 4.9, because that's a. Because remember, a, b, c. And then c is 25. Okay, so I'm going to do some of the work, negative 5 plus or minus square root of, and then that's going to be 25. So 25 minus 4 times negative 4.9 times 25 gives me 515 underneath the radical, all divided by negative 9.8. Okay, so we want a time. And if we want time, time needs to be positive. So if I take negative 5 and I add the square root of 515, I'm going to get a positive on top and divide it by a negative, and that would give me a negative time. I don't want to do that, and I don't want to waste time. Okay? So the only one I'm going to do is the negative part. So let me show you what I'm talking about on the calculator. You're going to type in negative 5 minus the square root of 515, get out from underneath that radical, and then divide by negative 9.8. And I don't know why it came out negative. Because it shouldn't have. Because it should be a negative divided by a negative. Oh, hold on. My calculator may not be in the right mode. No, it is. Okay, well, nice mess up on a video. Let's try it again. Square root of 515. I know what I did. I know what I did. I did a bad move. Hit equals before you divide by negative 9.8. The calculator, what happened, what I did is I did not tell the calculator to subtract first. So it followed order of operations, which is dividing first, and then combining it with a negative 5, which is incorrect, and that is my fault. But now I'm going to fix it. So now we divide by negative 9.8, and we get, I divided by negative 9.8 twice. But you divide by negative 9.8 once like you're supposed to, and you get about the 2.83 seconds. Okay? Now let me explain that again, because it's going to happen a lot. When you're looking for time, don't waste your time. You don't want to do negative 5 plus square root of 515, hit equals, divide by negative 9.8, because that will give you a negative. You can't have a negative time. So do the negative 5 minus the square root of 515, because I know the square root of 515 is bigger than 5. So if I take a positive bigger than a negative, I'm going to get a positive on top, and dividing by a negative will give me a negative. I can't have a negative time. So that's why I'm saying, you know, make sure you've got a negative in the numerator when you're dividing by this negative right here, okay? And this is exactly how you're going to do practice G. You're going to do practice G. I've given you an example or more example, lots of examples of just like what's on the practice, okay? I do want to show you one of them, though, because I noticed something kind of funny. So let me... let's see, which one is it? E. E looks a little funny, so let me look at something. This is E on the practice. So make sure that you get it worked with me. Copy it, okay? Because I think something weird happened, so I want you to see it. So I've got the x minus 12. And then that's 4x squared minus 3 minus 7x minus 2. And again, you can stop these and rewind them and watch them again, whatever. So that's x minus 12. This would be 4x squared minus 7x minus 1. Because that would be a negative 7x, that'd be a plus 2. So negative 3 plus 2, negative 3 plus 2 is minus 1. So I want to graph this and see. So 4x squared minus 7x minus 1. Graph. Okay, this is a plus 3 right there. Once again, mess up. So that plus 3 and this plus 2 would be a plus 5. Okay, so that should have been a plus 3. It was a plus 3 there. It should be a plus 3 here. Then that plus 3 and this plus 2, when this changes, gives me a plus 5. Because I shouldn't have any other zeros. I should not have had those x-intercepts. So what, that's 2 mistakes on the video? It shouldn't cross. See, it doesn't. It doesn't cross the x-intercept. So I wanted to show you that because sometimes that'll happen. So the only 0 we've got is the 12. That doesn't give you zeros. These would have non-real zeros, which we don't want. Okay, right now. Anyway, that's E on the practice. And so what you're going to do on 76 is you're going to do the warm-up, which is on page 540. You're going to do practice A through G. And then you're going to do, pick some out. You're going to do 1 through 6. 16, 27, 29, and 30. And then on number 4, just use a calculator. Just type it in the calculator. It's like the sine, cosine, and tangent of 270, so just type those in your calculator and write those down. Email me if you have any trouble on those before Wednesday. This is due Wednesday at 4, but I want you to email me before Wednesday if you have questions on it. Okay, peace out.